The BAS mining truck is designed for heavy-duty operations with a 50-ton payload and single-mounted tires. Equipped with a 540 HP engine and Powertronic gearbox, it delivers powerful performance while maintaining significantly lower fuel consumption and price. Featuring 4 steered axles for excellent maneuverability and hydraulic suspension on the driven axle, the truck ensures optimal handling. It can unload on inclines efficiently, completing the task in just 30 seconds, making it a highly effective solution for demanding mining environments. BAS Trucks has revolutionized mining transport with its specialized Volvo FMX trucks engineered for tough conditions. Each truck features a reinforced chassis, a 32-ton rear axle with hub reduction, and a powerful Powertronic gearbox with torque converter, enabling continuous traction. The FMX can carry up to 50 tons and 30 cubic meters of material, even over distances exceeding 1 kilometer. By adding a 13-ton axle, payload capacity is increased, while Hardox 500 steel plates reduce wear from abrasive loads. Operating globally, including at the Brand Gold Resources site in West Africa, BAS offers full service agreements covering parts supply, technical support, driver and mechanic training, and 24/7 assistance. The trucks demonstrate outstanding fuel efficiency, just 14.2 liters per hour, and optimized unloading time with a double-action cylinder and specially shaped tipper. With over 7,000 units sold annually in 93 countries and 300 million euros in turnover, BAS Trucks ensures maximum uptime, reliability, and cost-effectiveness. Their end-to-end support and engineering excellence set a new benchmark for the mining industry. At the coal mine, the XCMG unmanned wide-body dump truck operates autonomously throughout the entire transportation cycle. In the loading area, it collaborates with excavators, while its perception system continuously monitors and calculates the stopping distance in real time. The truck then enters driverless convoy operation, utilizing a multi-sensor fusion system that provides 360 degrees all-around awareness for safe navigation. Upon reaching the unloading zone, the vehicle precisely aligns with the unloading point and performs safe and efficient dumping. It also unloads at the crusher station with high accuracy. Even during complex conditions like nighttime reversing and uphill travel, intelligent algorithms ensure precise control of throttle and braking. This enables reliable and efficient raw coal transportation around the clock. The seamless coordination between perception, control, and unmanned driving technology showcases the advanced capabilities of XCMG in modernizing mining operations and improving safety, productivity, and automation in challenging environments. The Sandvik TH550B is a 50-ton battery-powered underground mining truck featuring the patented auto-swap system. This innovative technology enables quick, operator-controlled battery swapping directly from the cabin, eliminating the need for cranes or forklifts. Powered by 354 kilowatts batteries and delivering 540 kilowatts tractive power, it climbs ramps at 11.5 kilometers per hour and reaches a top speed of 38 kilometers per hour. The TH550B ensures zero emissions. The Dramis D150T is an off-road mining truck built on the Kenworth C500 chassis, engineered to haul 150 metric tons of gold ore over a 144 kilometers round trip on 8% gravel grades at 50 kilometers per hour. Powered by a Cummins X15 engine delivering 605 horsepower and 2,050 pound-feet of torque, it uses an Allison 662OA automatic transmission with a Namco transfer case. Key features include dual AMS 50 THD 50,000 pounds front suspensions, a 135,000 pounds DTS hydraulic rear suspension, and planetary rear axles. Its 240 cubic meters dump bodies maximize load capacity. Designed for extreme conditions, the D150T remains operational in temperatures as low as -45 degrees Celsius, making it ideal for demanding mining operations. The process begins by ensuring the heavy-duty truck is parked on a flat, stable surface with the parking brake engaged and wheel chocks in place. A hydraulic jack is used to lift the truck at the position of the damaged tire. Once lifted, safety stands or blocks are placed beneath the chassis for added support. Workers then use high-torque tools to loosen the lug nuts. A specialized tire handler forklift approaches and aligns its clamps with the tire's position. The old tire is removed and transported to the repair area. Next, the wheel hub area is cleaned using a high-pressure water hose. The forklift then secures a new tire and moves it to the axle. The tire is aligned precisely with the bolt holes, and the lug nuts are tightened to the specified torque. This ensures a safe and stable installation before the jack is lowered and equipment removed. Operating a heavy-duty truck demands meticulous attention to safety, thorough inspections, and precise execution of procedures to ensure the safety of personnel, equipment, and compliance with regulations. The process begins with the driver ensuring optimal physical and mental health, equipment protection, and adherence to workplace laws and norms. Drivers must consistently wear provided personal protective equipment, drive defensively, and respect traffic signals, speed limits, warning signs, and informational boards. Before operation, with the engine off, the driver conducts a pre-inspection, starting by checking the cabin and surroundings for nearby personnel. If no lockout is present, the truck is operational. The inspection begins at the front, moving right to left, checking hoses for wear and ensuring fan and air conditioning belts are properly tensioned and in good condition. The steering system, including tie rods, steering arms, and hydraulic hoses, is examined for damage, with all bolts and fasteners verified as secure. Nitrogen accumulators for emergency steering are also checked. The front and rear suspension cylinders are inspected for nitrogen or oil leaks, with bolts confirmed as tightened. The fuel tank is checked for secure bolts, intact supports, and welds free of leaks. Wheel nuts and connections must be tight, tires free of cracks, deep cuts or low pressure, and valve stems intact. Oil leaks from planetary gears or brake fluid are noted, and significant leaks prompt the driver to halt operations and notify dispatch or the supervisor. During hauling operations, the driver approaches the loading ramp at a reduced speed, using the first trip to assess the truck's condition and route risks, such as curves, road width, and dump site conditions. At the dump site, the driver maintains a maximum speed of 12 miles per hour, keeps a 10-meter distance from the berm, and ensures a 90-degree turn with at least 15 meters between trucks to prevent spills, operator risks, and equipment damage. When descending a ramp with a loaded truck, The driver uses the dynamic brake or retarder, maintains appropriate gear settings, stays on the dry section of the ramp, keeps a 60-meter distance from other equipment, avoids overtaking, and keeps driving lights on. For loading with a shovel, the driver coordinates via radio with the shovel operator and support teams to ensure a clear, obstacle-free area. The truck enters on the opposite side of the shovel's tail cable under normal conditions, aligning using a suspended cone as a reference, avoiding the shovel bucket. In adverse conditions, the driver waits for the shovel operator's signal before exiting at a moderate speed, avoiding spills. On slippery roads, the driver maintains the designated lane, reduces speed or stops for obstacles, and ensures visibility before overtaking. Speeds are capped at 20 miles per hour on flat roads and 8 miles per hour on ramps. If control is lost, the driver parks safely, activates warning lights, and notifies dispatch. In emergencies, such as mechanical failures, the driver remains calm, uses the retarder to reduce speed, stops near a safety berm, and reports the issue. For fueling, the truck aligns parallel to the pump, the driver applies the parking brake, turns off the engine, and exits using both hands. The fuel attendant applies and removes a lockout, and the driver signals with 2 horn blasts before exiting slowly. This rigorous process ensures safe and efficient heavy-duty truck operations. At the mine site, the CAT 797F mining truck operates with powerful performance and exceptional safety. Before operation, the crew checks safety features such as wide walkways, guardrails, and dual access ladders. The integrated ROPS structure and lockout/tagout systems enhance operator protection. Once loaded, the 797F accelerates quickly using its 20-cylinder, quad-turbocharged CAT C175 engine, delivering 4,000 horsepower, supported by a 7-speed planetary transmission and lock-up torque converter for efficient hauling. Despite its massive size, the truck maintains stability and control with 4-corner oil-cooled brakes and automatic retarding control. The truck reaches speeds of 60 kilometers per hour even on steep, rough roads, achieving optimal cycle times. During descents, it burns no fuel thanks to its advanced engine retarding function, improving efficiency. The Eco mode can reduce fuel use by up to 3.5% per cycle. Operators benefit from ergonomic controls, reduced noise, and a vibration-dampening seat. Maintenance is streamlined via grouped checkpoints, long-life filters, and optional electric start. Built with over 80% cast frame and designed for long life and rebuildability, the 797F excels in durability, comfort, and productivity, making it a key machine in demanding mining operations. At the mine, the Caterpillar 797 and Liebherr T282 operate in coordination with hydraulic excavators for large-scale overburden and ore transport. Initially, both trucks reverse toward the excavator, positioning their massive dump bodies precisely under the bucket. The excavator loads the material in several passes, carefully filling the body for optimal weight distribution. Once fully loaded, the Caterpillar 797 with its 400-ton payload and 4,000 horsepower diesel engine drives away using its mechanical powertrain to deliver consistent traction on rugged terrain. Its two-axle configuration ensures weight is spread evenly, enabling it to climb inclines while fully loaded. The operator inside the ROPS-certified cab monitors the vehicle's systems, including payload, engine performance, and terrain conditions. In parallel, the Liebherr T282 with a 360-ton payload and diesel-electric AC drive moves forward smoothly using torque from its electric motors. Its high ground clearance and lightweight chassis allow for reduced energy consumption and faster travel times. Equipped with a dual-circuit braking system, the T282 safely navigates long downhill stretches with dynamic retarding. Upon reaching the dump zone, both trucks position precisely and raise their bodies hydraulically to unload. The material cascades out rapidly due to steep body angles and polished liners. After dumping, they lower the beds and return for another cycle. This repetitive sequence of loading, hauling, and dumping maximizes mine productivity while utilizing each truck's design strengths: mechanical for the 797, electric for the T282. In the heart of a large, open-pit mine, massive haul trucks, such as the Caterpillar 797F and Liebherr T282, play central roles in moving material efficiently and safely. These machines, designed specifically for mining operations, can carry payloads up to 363 to 400 short tons in a single pass. Each shift, the trucks follow a well-orchestrated cycle. First, they journey to the loading zone, where giant shovels or wheel loaders deposit material into the box bed. The design of the dump body ensures stable loading and reliable containment during transport. Once loaded, the driver, or often an autonomous system, steers the truck onto haul roads. The CAT 797F uses a mechanical drivetrain powered by a 20-cylinder, quad-turbocharged engine producing nearly 4,000 horsepower. It transmits power through a 7-speed planetary transmission, achieving speeds up to 68 kilometers per hour fully loaded. In contrast, the Liebherr T282 employs diesel-electric for better efficiency and lower structural weight. During the haul, advanced safety systems guide operation: GPS, radar, cameras, and proximity detection alert drivers or fleet management systems to obstacles in other vehicles. Braking systems include engine retarding, service brakes, and multiple backup systems for emergency stops. Upon reaching the dump pit or crusher feed, the trucks carefully elevate their bodies to unload. In just minutes, they empty their load and prepare to return. Over the course of a shift, this loop repeats dozens of times, with each cycle tightly coordinated with other fleet equipment. Routine service is essential. Tires alone cost tens of thousands each and require regular inspection. Scheduled maintenance includes engine tune-ups, transmission servicing, brake checks, and scheduled component rebuilds. Caterpillar targets over 90% machine availability. Through this process, these haul trucks form the backbone of modern mining logistics, transporting massive loads over rugged terrain precisely and efficiently to keep production moving. The Caterpillar 797 begins its iron ore hauling cycle by moving steadily out of the mining area, carrying a nominal payload of 400 tons. After being loaded by a large mining excavator, the truck fires up its powerful 4,000 horsepower, 20-cylinder CAT C175 engine to begin its journey. As it begins to accelerate, the truck's 7-speed planetary transfer case delivers consistent power across a wide range of speeds. Thanks to a 23% increase in net torque, it provides unparalleled traction, allowing the fully loaded truck to accelerate quickly. The truck then heads to an uphill haulage route, a key test of the truck's power and traction. As it climbs, the Caterpillar 797 maintains a strong and steady speed, even in poor underfoot conditions and high rolling resistance. Advanced powertrains and lock-up torque converters ensure excellent control and acceleration on steep grades. Wide aisles, guardrails, and ROPS construction enhance operational safety, while the CAT MineStar Detect system alerts operators to nearby hazards. During steep-grade climbing, the truck demonstrates stability, reliability, and performance under extreme load and terrain conditions. The unloading process of the CAT 797F mining truck begins as the fully loaded vehicle approaches the designated dumping area. Once in position, the driver activates the hydraulic system to raise the massive dump body. As the body tilts upward, the tailgate swings open, allowing the heavy load of material to slide out by gravity. The truck's rugged frame and massive 13-foot tires provide stability during the lift, ensuring smooth discharge even under the weight of 400 tons. Meanwhile, the efficient 7-speed planetary power shift transmission and the C17520 engine work together to maintain steady engine performance throughout the process. The lock-up torque converter enhances power transfer, helping the truck hold its position while dumping. Dust clouds rise as the load hits the ground, signaling a successful release. After unloading, the dump body is lowered smoothly, and the truck exits the site, ready for the next haul. Throughout the process, the 797F demonstrates high efficiency, durability, and cost-effectiveness, making it ideal for large-scale mining operations. Caterpillar wheel loaders work on a mining site by efficiently scooping and loading material into large mining trucks. As the machine approaches the pile, the operator lowers the bucket and begins the scooping phase. The lift arms, equipped with a Z-link, provide powerful braking forces and clear visibility of the bucket edges, allowing for precise loading. With powerful hydraulics and electronic joystick control, the loader dumps the bucket in one quick motion and backs up with minimal tire slippage thanks to the rim pull control system. Next, the operator steers the loader toward the waiting dump truck. The STIC control system simplifies direction and steering changes via a single lever, allowing for faster cycle times and reduced operator fatigue. Once in position, the wheel loader lifts its bucket using a positive flow control hydraulic system, ensuring smooth, consistent lifting even under heavy loads. The wheel loader's structure, with stress-relieving lift arms and a box frame, supports high-power operation and absorbs dynamic forces during material transfer. Once aligned with the truck bed, the bucket tilts forward for precise material dumping. Integrated electrohydraulic controls allow for rapid dumping with preset kickout positions, increasing speed and accuracy. The wheel loader then reverses to repeat the cycle. The wheel loader can operate on any mining site, anywhere. During operation, the wheel loader's 3516E engine delivers 1739 net HP, supporting rapid acceleration and digging performance when fully loaded. Advanced filtration, cooling, and onboard diagnostics ensure uninterrupted operation in harsh environments. The wheel loader cab offers a climate-controlled, vibration-isolated workspace for optimal operator comfort. The loader's cab provides a vibration-isolated, climate-controlled workspace for optimal operator comfort. With powerful systems working in harmony, the Caterpillar wheel loader ensures high productivity and reliability in every mining load cycle. The extraction process in large-scale mining operations relies heavily on giant trucks with massive load capacities. These machines transport materials like gold, copper, and iron across vast mining sites. Among them, the electrode dumper operating in Switzerland stands out as the world's largest electric vehicle, using high-performance lithium batteries to carry up to 65 tons. The Sandvik SRT95C, with a 95-ton capacity, features advanced safety systems and a powerful 1050 HP engine. The Volvo R100 is engineered for fuel efficiency and productivity, hauling 95 tons with a 1,065 horsepower engine. The Dramis D150T, designed for operational safety, moves 70 tons and reaches 42 miles per hour. Australia's 5-axle BIS truck with 20 tires hauls up to 160 tons while cutting fuel consumption by 40%. The legendary Liebherr T282, used in gold, copper, and iron mining, can carry 360 tons, powered by a 3,650 HP diesel engine. The Caterpillar 797F, built in 2009, handles 363 tons and is a staple in high-production mines. Komatsu 960E1, another massive hauler, transports 326 tons with a 3,800 horsepower engine. The Hitachi EH5000AC3 is praised for its efficiency and low maintenance, carrying 296 tons with a 2,850 horsepower engine. Topping the list, the Belaz 75710, manufactured in Belarus, supports a record-breaking 450-ton payload, powered by two 3,430 HP diesel engines. Together, these titans of mining ensure efficient material transport, reduced operational costs, and increased productivity in some of the world's largest and toughest mining environments. The Caterpillar 797F is a high-performance mining truck powered by a 4,000 horsepower Cat C 17520 engine. It offers faster speeds on grade, improved serviceability with ground-level access, enhanced safety through wider stairs, and a new ergonomic cab for greater operator comfort. Before operating the Sandvik TH550B underground truck, a thorough pre-operational inspection must be carried out. Begin by checking the general surroundings of the equipment. Then inspect the upper compartment, ensuring the engine is idling, the brake is applied, the gear is in neutral, and the oil is at operating temperature. Check the transmission oil level, the rear compartment, hydraulic and brake oil levels, and ensure all articulations are properly greased. Warning and danger labels must be in good condition. Wheel nuts should be tight and intact. Inspect engine oil level, look for leaks in the fuel and oil filters, and ensure the fire extinguisher is present. Check the fuel tank, water separator filter, and engine coolant level. Inspect the fire suppression actuator and verify the hydraulic tank pressure is 0.5 bars. Ensure all lights are functional. On the control panel, check that opening the door activates the parking brake and verify the alarm indicators. The assembly process of this ultra-class mining truck begins with the delivery and positioning of the massive frame. Skilled technicians install the front and rear suspension systems using heavy equipment. The electric drive components, including the alternator and traction motors, are then mounted onto the chassis. Next, the massive Komatsu SSDA18V170 diesel engine is carefully lowered into place. After engine installation, the cooling system featuring a split-flow L&M radiator is connected. Workers then attach the full-sized steel body, ensuring proper alignment and securing it with heavy-duty welds and bolts. The operator cab is lifted and fixed on top of the frame, meeting strict ISO 3471 and ISO 3449 standards for ROPS and FOPS. Following this, technicians install hydraulic lines, electrical systems, and the robust braking system. Final checks are made on alignment, torque settings, and electronic calibrations. Once the assembly is complete, the truck undergoes functional testing before being deployed to mining operations. The process reflects the collaboration of many workers united in a shared goal: